All right, so for this video, we are going to be focusing on linear functions and slope. So we're going to be going through definitions of slope. We're going to be mainly focusing on how do we write equations of line in point slope and slope intercept form, and then how do we graph also. So let's go ahead and get started. So slope is typically represented by the letter M in most scenarios here. So if you're going to see slope in a formula here, so here in a little bit, we're going to talk about point slope. The letter M represents slope. Again, slope intercept form, the letter M represents slope. So when you see in an equation, M is your slope. So M, the French word for slope starts with an M, I believe, and that's why that was used. Now, sometimes depending on what you're doing with graphing, sometimes you're graphing, sometimes you're writing equations of lines. Sometimes you're just given different information that you're going to need to calculate or do some things in order to graph or in order to write an equation of a line. If you need to find slope and you're given 2 points, so here in a little bit, we're going to find slope here. We're given an example where we have this point, and we want to find the slope between them. So anytime you're given 2 points and you want to find slope, this is the slope formula. All right, slope is equal to y2 minus y1 over x2 minus x1. So we would essentially just label, take whatever your first point is, make that your x1, y1. Your second point would be x2, y2. Plug into the formula, calculate it. If you notice, our numerators is the difference between the y2 and y1, right? Take the second y, subtract the first y from it. So slope is also described as the change in y over the change in x, which essentially in a nutshell is how much are we going up? How much are we going over from one point to the next? So rise over run. How much do we rise? How much do we run? How much do we rise? How much do we run? And so forth. So your upward movement, your side to side movement is kind of how you want to think about that. So we have two main forms of a line, point slope and slope intercept form. A lot of students nowadays focus on the point slope form of a line, but I believe that the slope intercept form is the better out of the two options. This one is more practical when we're trying to actually gather some information from our equation and use it to easily graph. So for the most part, with most of the examples that we're going to be going through in this particular video, when we write equations of lines, we're going to do it in both forms. We're going to write the equation in point slope. We're also going to write the equation in slope intercept form. So we will refer back to these equations here in a little bit. But let's go ahead and just get started here. So first, before we do any graphing, before we do any equations of lines, let's make sure that we know how to graph slope. Because regardless if we're working with the point slope or slope intercept, we need to know the slope for both of them. So we're going to need to plug in for this m here, regardless which equation. Now, sometimes you'll be given points. And if you're given points and expected to find slope, you want to use that slope formula right over here. Y2 minus y1 over x2 minus x1. So I already have the points labeled. So y2 minus y1, which is a negative 1, over x2 minus x1 is a negative 3. And just simplify this. It's really just a subtraction problem here. Double negative rule in the numerator, 4 minus a negative 4, that is going to cancel out and make that a 5. Over double negative rule once again here is going to cancel out, making that a negative 2 plus 3, which is a 1. And 5 over 1 does reduce to a 5. So this is telling us that we have a positive 5 slope. So keep in mind, positive slopes are going to go this direction. Negative slopes are going to go this direction. In math, you always want to look at graphs from left to right. So always think about it this way. Left to right, am I going upstairs or am I going downstairs, right? Where would you be climbing? Upstairs is your positive slope. Downstairs is your negative slope. Let's go ahead and find slope here for example B. Now in example B, if we're given an equation and we want to pick the slope out of it, you want to put that equation in slope intercept form. Or in a nutshell, that essentially is telling us solve for y. Notice that slope intercept form is y equals everything else, right? So if you're given an equation, go ahead and solve it for y. That's going to put it in this form. And then it's just going to be a matter of literally picking out the slope from the equation. So this is what that's going to look like. Let's solve this equation for y. So let's go ahead and get rid of this 3x. So we're going to minus that 3x on each side. It'll cancel on the left-hand side. Drop down that 5y is equal to. Proper form, drop down the minus 3x first. Always put your number at the end. Again, we want it proper form, so your x term first, then your plus or minus the number behind it. We almost have it solved for y. All we need to do is get rid of that 5. So let's divide everything by a 5, which will leave us with y is equal to, again, this is not reducible, so just drop that down, negative 3/5 x minus 15 over 5 is a 3. This would be our equation in slope-intercept form. That's not what this question is asking for, though. This question is just asking us to find the slope. Once your equation is in slope-intercept form, your slope is that m right over there. It is the coefficient of your x. So if we take a look at our equation here, right in front of the x is that negative 3/5. So our slope for this is a negative 3/5. If we were to graph this, our line needs to be going in this negative direction here. It'd be going, like, let's say we have a point, up 3 over 5, down 3 over 5, and you would connect dots like that. Now, for our next two examples here, we're going to write the equation of the line in both point slope and in slope-intercept form. So let's go directly here to C. So this is telling us that we want to write the equation of the line that goes through the point, negative 1, 3, and that has a slope of a 4. And we're going to write both forms. We're going to write it in point slope. We're going to write it in slope-intercept form. So I find it easiest just to go ahead and start with point slope, and then we will use that form of the line to just switch it over to this one so that we can have both of them. So point slope. When we're plugging into point slope, so just like the title says, we need to be able to plug in a point, which is your x1, y1. We also need to be able to plug in our slope right over here. This x, this y are standard. They're going to stay in the equation. So we need to plug in this x1, y1, and then we need to plug in for the m. And taking a look at the information they gave us, they actually gave us an x1, y1. They gave us a known point, and they gave us the slope. So they actually gave us everything that we need to be able to plug into this equation here. So let's directly plug in. That's going to look like y minus our y1, which they told us here is a 3, is equal to our m. Well, they also gave us that. That's a 4 right here. Open parentheses, x minus our x1, which here is our x, which is a minus 1. That is what it looks like when we plug directly into the point slope formula, which means we almost have our first form of our line. The only thing we need to do is simplify anything that's necessary here, which for us is going to mean this double negative rule here. Y minus 3 is fine, is equal to that 4. This double negative rule here is going to make that x plus 1, and there is our equation in point slope form. Now, we also want to write this equation in slope-intercept form. So I'm actually going to rewrite the equation, and what we're going to do is we're just going to take this equation, turn it into slope-intercept form. All we need to do is solve for y. In order to get y by itself, it's always going to be 2 steps. Whatever the number is over here next to y, move that over to the other side, so plus or minus it to the other side, just depending. Distribute your slope here. Whatever number's in front of your parentheses, you want to go ahead and distribute that out. And we're going to move this 3 over, so we're going to add 3 to the other side. That will then look like y is equal to, well, when we distribute, 4 times x is 4x, plus 4 times 1 is a 4. Drop down this plus 3 that we moved over to the other side. Combine your like terms, and in slope-intercept form, y is equal to 4x plus 7. So let's do that all over again here with example D. If we take a look at example D, we're not given a point and a slope. We're given 2 different points, and we're asked to do the same thing. Give me the equation in slope-intercept form. Give me the equation in point-slope form. So we're going to go through the same process we did over here, but with differing information. So keep in mind, in order to plug in to point slope, we need a point, which we have. We have 2 points. When you're given 2 points, you can choose whichever point you want. You can choose this first point to be your x1, y1, or this one to be your x1, y1. I tend to just go with whichever the first point is and kind of just go with that one there. So we do have our point. What we don't have is our slope. We don't know what our slope is here. We're not given an m, but we are given 2 points. And as long as we have 2 points, we can find slope by plugging it into that slope formula. y2 minus y1, x2 minus x1. So let's go ahead and label the second point here, x2, y2, and let's find slope. That would look like y2 minus y1 over x2 minus x1. Subtract here. Double negative rule up top is going to make that a 9 over -2 minus a 4 is a -6. When we reduce this fraction, and we can reduce it by dividing out a 3, that is going to give us a -3/2 for our slope. So I'm going to go ahead and just write that in over here. We now know what our slope is. We can use either one of these 2 points in order to write our equation. Starting with point slope, that's going to look like y minus our y1 is equal to our m, which is a -3/2, times x minus our x1. Simplify any double negative rules, otherwise that is our equation in point slope. We have this double negative rule right up front, so that minus negative is now going to be y plus 3 is equal to -3/2 x minus 4. That's our equation in point slope. So once again, I'm going to drop this equation down so that we can tweak this equation and turn it into slope-intercept form. Move the number over to the other side. Distribute the number in front of your parentheses. So I'm going to say -3 on each side so that we have y is equal to, well, when we distribute the -3/2, we get -3/2 x here plus, right, minus a negative is a positive, 3/2 times 4. You can put that over 4, that 4 over 1. Keep in mind numerator times numerator. 3 times 4 is a 12. Divided by that 2 in the denominator makes that a 6. Don't forget about the -3 here that we moved over to the other side. When we subtract those together, we are left with y is equal to -3/2 x plus a 3 for our equation in slope-intercept form. Now, the next handful of examples are going to pertain to graphing lines. Now, I'm going to specifically focus on taking these equations of lines, putting them in slope-intercept form, and using that to graph. Before we jump into that, real quickly here, most things in math, most topics that you learn, you have your general cases and then you have your special cases. Same thing pertains to graphing. You're going to have your special types of lines. Those special types of lines are called your horizontal and your vertical lines here. A straight horizontal line is going to look like a y equals equation. A straight vertical line is going to look like an x equals. So maybe, you know, something like example G here, notice we only have an x in the equation, whereas most equations are going to have your x and your y. Again, keep in mind f of x is y. So this is y equals 3/4 x minus 2. Y equals -1/3 x. But over here, we only have an x. And on an example down over here, we only have a y. If you only have one variable in your equation, that's a big hint. This is a special case. Is it a y equals? Is it an x equals? If it is a y equals, you are going to go up or down on your y axis, just depending on what that number says. And you're going to draw a straight horizontal line at that value. If it is an x equals equation, you're going to be using your x-axis, and you're going to move over left or right, whatever that number says, and you are going to draw a vertical line. That's as far as you need to graph. A straight horizontal line, straight vertical line. A y equals graph has a 0 slope. A x equals graph has an undefined slope. Otherwise, they're pretty simple to actually graph. Now, most of your cases are going to be a regular equation that has an x and a y in it. So for us, we are going to first put everything in slope-intercept form. Once everything is slope-intercept form, you want to first plot your y-intercept. Your y-intercept is always going to be that plus or minus number hanging out at the back of the equation. Again, keep in mind slope-intercept form, y equals mx plus b. This plus or minus b over here at the end is your y-intercept. You're just going to go up or down, whatever that number says, and plot that value. Then you will take a look at your slope. Depending on your slope, again, you are either going to plot a positive slope or a negative slope. If you are plotting a positive slope, right, from any given point, in order to plot positive slope from a point, you are going up and to the right or down and to the left. And that's going to give you that positive movement. Again, always think about it. If you're standing on this line, are you climbing uphill or downhill? All right, that's a good way to sit there and let you know, did you graph the proper slope? If you are graphing a negative slope from any given point, you're going to be going up and to the left or down and to the right to do that negative movement. Or again, picture yourself walking on that line. Again, are you going uphill? Are you going downhill? The biggest mistake that most students make in graphing is graphing the opposite slope, graphing a positive when it should have been negative, or vice versa. So do try and be hyper aware of that. Otherwise, let's jump straight into these examples. Example E, we are going to graph y is equal to 3/4 x minus 2. First off, this is a positive slope, so our graph should be going in this movement. Always start with your y-intercept over here, though. Our y-intercept for this example is a minus 2. That means straight from the origin, go down 2, plot your y-intercept. From that point, we will be plotting a positive 3/4 slope. Again, positive is up and to the right, down and to the left. Up 3 over 4, up 3 over 4, right? Rise over run. Your numerator is your up and down. Your denominator is your left and right. So from this point, up 3 over 4. So up 3, 1, 2, 3, over 4, 1, 2, 3, 4, right over there. Also down 3, 1, 2, 3, over 4, 1, 2, 3, 4. The lines, your points should line up. Connect the dots. There is your graph. Let's do this all over again. Here with example F, we have f of x is equal to negative 1/3 x. Negative slope here, so our graph should be following the negative direction. Notice we do not have a plus or minus number hanging out at the back of the equation over here. If that is so, that means that your y-intercept is a 0. Think of this as being a plus 0. So that we're just going to put a point right there at the origin. From that point, negative 1/3 slope. Up 1 over 3, up 1 over 3, but in the negative direction, which means up and to the left, down and to the right. Up 1 over 3, down 1 over 3. Connect your dots, and that's what that one would look like. Example G is one of our special cases. Notice we only have an x in this equation here, so that's your big sign that it is a special case. Solve for the variable here. So you want to get that x completely by itself. So add 18 to the other side, which gives us 3x is equal to 18. Divide out the 3 on each side, and x is equal to a 6. That is your equation of your line. So what you want to do, this is an x equals. If you have an x equals, it is a vertical line at that number. So we are going to draw a vertical line at a positive 6. Positive 6 on your x-axis is right over here. Draw a vertical line, and that is your graph. If we move down to example F, again, we're just graphing here. So notice this equation is not given to us in slope-intercept form. It is not y equals. So the first thing we're going to do here is put it in slope-intercept form. So I'm going to subtract 2x on each side, making that negative 3y is equal to negative 2x minus 6. Then you want to divide that negative 3 out, so we're going to divide everything by that negative 3, making that y is equal to negative over negative cancels, and we have a 2/3 x. Negative over negative is a positive, and we get a 2 there. So for this one here, we are looking at graphing a positive 2/3 x plus a 2. So that means we're going to plot our y-intercept first. Our y-intercept for this example is a positive 2. From your origin, go straight up 2. We have a positive 2/3 slope. So again, positive direction, up 2 over 3, up 2 over 3. So up 2, 1, 2, over 3 in the positive direction, down 2, over 3 and connect your dots. Last example here. Last example is also a special case. If you look at this example here, we only have a y in our equation. Solve for that y by adding 3 on each side, and we are left with y is equal to -3. That means we are dealing with our y-axis, so go to a -3 on your y and draw a straight horizontal line. Again, keep in mind a y equals is a horizontal line at that value, so a straight horizontal line at a -3. The last thing in this video is going to be using intercepts in order to graph. Now, there's multiple ways to graph. One of the first ways that most students are learned how to graph is by doing an XY table. You can do an XY table, and this technique of graphing still works regardless what type of graph you are trying to do. Pick some values for X, plug them into your equation, solve for Y, get some other points, and these are going to represent, the points on your graph. Plot the points, connect the dots. That's one of the first way most people are taught how to graph a line. And then people are taught how to use slope-intercept form, what we just went over. A third technique is using intercepts to graph. Now, using intercepts to graph is a nice technique because if we look, our x-intercept is where our line crosses the x-axis. Our y-intercept is where our line crosses the y-axis. So when we find the x and y-intercept, it gives us 2 points. And as long as we have 2 points, we can graph any line. Now, using the intercepts is a nice technique in order to graph because if we take a look at our definition here, in order to find the x-intercept, you want to plug in 0 for y and solve. In order to find the y-intercept, you're going to be plugging in 0 for x and solve. And plugging in zeros for math is really nice because zeros tend to make our calculations a little simpler. So this is definitely a favorite technique amongst students. So let's talk about how to graph these using intercepts. So we are going to find the x-intercept and then the y-intercept and use those 2 points in order to graph. When we find the x-intercept, we are plugging in a 0 for y and solving. When we plug in 0 for y, it's going to make that middle term disappear, leaving us with 4x minus 6 is equal to 0. Add that 6 to the other side, divide by the 4, and x is equal to, well, when reduce here, x is equal to a 3/2. Keep in mind that an x-intercept is an actual point. So your x-intercept is not just 3/2. It is the point made from that. A point is made up of an x and a y value. So our x is 3/2. Remember that we plugged in 0 for y. So our x-intercept is actually a 3/2 comma 0. Find the y-intercept. In order to find the y-intercept, we're taking our same equation, but now we are going to plug in 0 for x, and we are going to solve this one here. That front term is going to disappear, leaving us with a -3y minus 6. So add that 6 to the other side. Divide out your coefficient, and we are left that y is a -2. Complete the point. We plugged in 0 for x, got -2 for y, so there are our x and our y-intercepts. But this question is asking us to graph, not just calculate. So now we need to graph this equation here by plotting these points and connecting the dots. Positive 3/2 and a 0, so 3/2 is 1.5. 0 is going to stay put there. And then we have a 0, -2, which is right over there. Connect those dots, and that is what our graph would be of this line using those intercepts. Let's do this again. All right, one more equation here. Let's find our x-intercept. Again, you find the x by plugging in 0 for the y and calculating. That's going to make this term disappear, leaving us with 8x plus 12 is equal to 0. Solve for that x. Subtract that 12 on the other side. Divide by the coefficient. And when we divide here, we can reduce by a power of 4. So we get a -3/2 for our x. That means our x-intercept is -3/2, comma 0. When we find the y-intercept, again, same equation, but now we are plugging in 0 for our x. That front term is going to disappear, so we're going to solve the remaining equation here. Subtract 12 on each side. Divide by the -2, and y is equal to a 6. So my y-intercept there is a 0, 6. So let's go ahead and create our graph here. Again, we're just going to plot our intercepts, connect the dots. So -3/2 is a -1.5, 0, right over there. And then 0, 6, so I'm going to go straight up 6 and plot that. So this is what that graph would look like.